Fourth grade, we're going to begin science. Let's start out with a little bit of review. What's the layer of air surrounding the Earth? This is the atmosphere. And what keeps the atmosphere from floating away? It is gravity. How far does the atmosphere extend into the air? It extends about 1,000 miles. Now, besides the atmosphere, where else could we find air? Jackson? We could find it in the dirt, and we can also, like in the soil, we can also find it in water. You can find it in your water. Now, what gas do plants take from the air in order to make food? Now, they can use nitrogen, but the one that they take in order to make food is carbon dioxide, because we use carbon dioxide for photosynthesis. All right, I hope you knew those. What gas is important for animals and people, mainly people? Oxygen is important. Okay, to review from yesterday and the quiz, what is the ability to do work? This is energy. And then when we talk about a push or a pull on the object, it is the force, okay? The force is strong with this one. Okay, this is the force, is a push or a pull. Work is not done until an object is moved, all right? Then we're talking about potential energy and moving energy. Which one's stored energy? It's potential energy. Now, if we have energy and we want to make it into our water to turn into steam, what would we need to make it into steam? We would need to add heat to it. Let's see. Now remember, I think some of you had a little bit of difficulty with this on the quiz, but remember, water is different than most liquids. Most liquids, when they freeze, they shrink, okay? Or they contract. Contract means they get smaller, okay? So if we took something, random, most liquids, and we would freeze them, like maybe mercury or something, it would shrink down. However, water is opposite. Like when you fill your ice cube tray, or make sure you don't fill it all the way, because water expands. The reason why this is helpful in nature is so all the plants and animals don't die, because water expands, and then remember, it floats over it's over the top layer, and this ensures that all the plants and the animals don't die, because if it would pile up at the bottom, all the animals and plants would die, and so God was looking out for them. We talked about melting point is the same as freezing point, and it is 32 degrees Fahrenheit. And boiling point is 212 degrees Fahrenheit. What causes objects to float in water? This is surface tension. Now today we're going to be talking about air, and we're on page 115. Air has weight and pressure. It's got some pressure and it has some weight. You might have heard the expression, we're reading along, you can follow along, light as air. Well, you might have thought that air does not weigh anything. After all, air does not feel heavy. But air does have weight. A cubic foot of air weighs just about 1 ounce. It would be impossible for you to measure air by itself, but you and Franken tried the demonstration, which shows that air does have weight. The Bible talks about the weight of the winds long before scientists learned that air has weight. Since air has weight and takes up space, it is matter. So air has weight, and how you can prove it is if you go to page 116. You can try this experiment at home if you have 2 balloons. You can try this at home where you take 2 balloons, you blow up one balloon and you tie it to the end of a ruler or something, and then at the other end, you have the balloon that's not blown up. Now, if you do this correctly, you can test the theory, and it will show that which one do you think is going to be heavier? The one that has all the air inside or the one that's not blown up? Yes, the one that has all the air inside is going to be heavier and it's going to weigh it down. And this proves that air has weight because they're exact same thing, they're the exact same balloon, except one has weight and one does not. Our next thing is air has pressure. Because air has weight, it creates pressure, right? Anything with weight has pressure. Now, if I have my glasses right here, that's not a lot of pressure on my head. But if I had an elephant, there's a lot more weight, and if it were sitting on my head, well, it would crush me and I would die. But if we had the bigger the weight, the more pressure, right? So pressure is the measurement of the force that matter exerts over a certain amount of area. Solids exert pressure. If you have ever pressed flowers, have any of you girls ever done this, or seen your moms do this maybe? Take fresh flowers and they press them in a book. Because of the pressure, it will help to flatten the flowers. Liquids exert pressure too. You could feel the force of water pressure if you put your hand over the end of a garden hose when it's turned on. If you've ever been in a swimming pool and you have gone on the sides and you felt the water coming out, there's some pressure on the sides when the water's coming out. If you have a hose and you put your finger on top of the hose, you can actually get the water to squirt at a higher pressure, because if you cut some of the water supply off, it's gonna with your fingers, you're going to feel the pressure of the water. Gases also exert pressure. You may want to try the demonstration below in order to observe air pressure. So we can do this today. If you follow me, I'm going to take you around to our classroom. What you're going to do is we're going to observe that air has pressure. Oh, this is great. Air has pressure, and what we're going to do is we're going to take one of my cups and we're going to fill it up with water. You can try this one at home too. If you guys do try these at home, comment and let me know how this works out for you. Okay, but make sure you have your parents' approval because we don't want to make a huge mess. So, to prove that air has pressure, what you're going to do is you're going to fill this up with water. Fill your glass cup up with water. Now I'm using a mug and that's fine. What I'm going to do next is I'm going to find a piece of cardboard. So you're going to find a piece of cardboard and put it on top. Okay? Now very carefully, oops, not like me because I just spilled some because I wasn't careful. So what you're going to do is you're going to hold the cardboard like this, hold it in place. And what you're going to do is you're going to turn it upside down very carefully, all right? Now, what you're going to do is you're going to hold onto the handle and let go. Now, the reason why this holds and does not and water does not go everywhere is because of the air pressure. I got to be very careful though, because if I start moving this glass around, all the water is going to come flying out and get me all wet. Now, air pressure is holding this cardboard in place, keeping the water in. And now I can just dump the water out. So isn't that cool? You can try this at home and let me know how it works. Now, this is kind of actually really bad, but we did this, I think, when I taught second grade. You can actually do it, and you can set it on something, but I wouldn't do that at home. Because what's going to happen is eventually you're going to have to pull it up and then somebody's going to get soaking wet. But like I said, you can try this at home. And it's just so cool because you fill up this. All you have to do is prove that water has pressure by just putting it on top, flipping it carefully upside down, and the pressure is what keeps it together. Oh my word. If you're not careful though, you will get soaking wet, like I just did. All right, so You saw it work. You saw it not work. So like I said, be really careful. Okay, so air has pressure, and we said air has weight. Now air pressure changes, and I have definitely found this to be true because when you have constant hot and cold, like you know how our weather was nice and hot, then it got cold. Whenever it goes from really hot to really cold, I get, I was gonna say headaches, but that's not, this is not your head. I mean, this is your head. These are your cheeks. Wow, I need to go back to kindergarten. Okay, well, anyways, like I said, I get lots of pressure here from the cold air and the different things, and it actually gives me like almost like a sinus kind of headache from the pressure. Well, air pressure changes. Do you remember how far up the atmosphere extends? Remember, it goes up about 1,000 miles, and every bit of that air, which goes up for 1,000 miles, has weight. So think about 1,000 miles of air's weight, all right? So the weight of all the air in the atmosphere creates pressure as it presses down. Now, I do this experiment when you guys are here, but nobody's here. If you have to decide, where do you think is going to be the most pressure? The higher up you go, or the lower that you go, or the lower you go? Well, air pressure is pressing down. Remember, gravity is pulling down. So the ones that have the most pressure is the further down you are. If you are higher up in elevation, you'll have less pressure. I prove this to people because if we had a bunch of people, let's say the boys just started piling on top of each other. They're playing tackle football and they all went and tackled each other, okay? Let's say that Joshua jumped for the ball first, and then Steven landed on top of him, and then Isaiah landed on top of him, and Nicholas landed on top of him, and Anthony landed on top of him, and then you have all the boys, Isaiah, Evan, Jediah, all in a big sandwich, okay? Who's going to get the most pressure and the most crushed? All right. The person at the bottom is obviously going to get the most crushed, okay? Because the person at the bottom has the most pressure. The same is true with air pressure. The further down you go is the more weight and the more pressure pushing down on you. Did you know that there's about 2,000 pounds of pressure all around you, but you don't feel it because it's completely all around you. You've got a lot of pressure on you. Now you might notice that the air pressure changes when you go on an airplane. If you've ever been on an airplane and you've gotten on a flight, and when you are in there, do you ever notice your ears popping? What's happening is your ears are trying to adjust to the different pressure, okay? When your eardrums finally pop and they're not clogged anymore, it means that the pressure on both sides of your ears has equaled out. Now, it's later talking about how when you can watch air pressure as you're drinking and you drink through a straw. The straw, when you put it in your glass, it looks empty, right? Right? You hope there's no liquids in there, but it actually has air inside. So when you put it into the glass, it's full of air until whatever you're drinking fills it. And then when you put the straw into the glass of liquid, the liquid goes up into the straw and it forces the air out. The air comes out as the liquid fills the glass. And then when you suck on the straw, all the air that was in there, you actually take it out when you're sucking up in the straw. And the air pressure now in the straw is less than the air pressure on the outside of the straw. And then what happens is the straw works because all the air outside pushes down, which forces the liquid up the straw and into your mouth. And you might have noticed that it doesn't work when there's a hole in your straw, because now the pressure inside is not less than the outside. Also, if you look at the bottom of page 117, this is the bird that we would have been coloring today, and this reminds me of Zoe from California, and also Evan, who lived in Coloring for a little bit, but this is your California gull. The California gull is the state bird of Utah, not California. Go figure, right? Well, you're going to be coloring about the California, well, you would be coloring the California gull, but you can't because we didn't take our book home, but just be reading about it today and seeing the California gull. I hate seagulls because whenever I go to the beach, I think I told you this, but when I had a piece of pizza and I was at the beach and I was walking with my friends, and the seagull came down and took a bite out of my pizza, and then I went like this with my plate, and I actually caught its claws in there for a second, and then that kind of like scared me, so I like let go, and all these seagulls started chasing me. I started taking off running, and they were flying behind me, and I threw the pizza into the trash can, and all the birds dove into the trash can. So since then, I do not like seagulls. I think they're ugly and gross. Okay, but you're going to be learning about the California gull today, and read your pages, page 115 through 118, and see if you can answer these questions. Okay, true or false? Air is matter. True, it is true. Air weighs less than an equal amount of a solid or a liquid. That's true. That's true. If you had your hand sanitizer and it's this much with hand sanitizer and this much with air, this obviously would weigh more. Although solids exert pressure, liquids and gases do not. That is false. I mean, think about if we had a big pool of water, which is liquid, and we dumped it on your head. You would definitely feel the pressure of that, right? Number 6, air pressure at the top of a high mountain is equal to the pressure at sea level. That is false as well. Where did we say the pressure is more? Yeah, at your sea level. And number 5, you do not feel air pressing down on you because pressure on all sides is equal. That is true. That is true. You have air all around you, and it's so equal that you don't even feel it. That's it for today in science. Make sure you read those pages, and I will see you next time.